Yeah, thank you for your kind introduction, and thanks everybody. It's a pleasure to be here and participate in this event. And today I will talk about some of our research activities which are carried out in collaboration with Dr. Alessandro Simeone from Shantou University. And it deals with the development of an intelligent cloud manufacturing platform with the aim to improve the resource efficiency in smart manufacturing networks. Well, as you know, the optimization of resource efficiency in manufacturing industry is a main concern nowadays because we have frequent variations of the global demand. So we have variations of the production volumes and we have to adapt the production plans. And this is true for several industrial sectors. And this problem is particularly felt, for example, in the sheet metal cutting sector, where many manufacturing companies are producing with smaller lot sizes, and this negatively affects the resource efficiency. And so a solution in this case can be obtained by opening the boundaries of factories so that we can combine, for example, multiple orders on the same material that can be carried out together. So if we open the boundaries of the single factories and we create smart manufacturing networks, then we have more chances to fulfill the manufacturing task by combining the several orders with the aim in particular to reduce the material waste. And the chances are more because we connect multiple customers and multiple suppliers at a global scale. And in this framework, then, the aim of this particular research project is to develop an intelligent cloud manufacturing platform, allowing for the dynamic sharing of sheet metal cutting services to realize a smart production network with increased resource efficiency. And why are we focusing in particular on the sheet metal cutting sector? The reason is that the optimization for these processes is mainly driven by the decrease of the scrap percentage, as material is the main cost component, and the cutting machines, considering the different technologies, for example, punching, laser, water jet, well, these processes can generate a scrap percentage that can reach 15% and more. And so to improve the resource efficiency of these processes, often nesting is applied by combining different parts on the same sheet, on the same material, and to reduce the amount of waste material, which depends on the geometries of the different parts which are combined. And so in this sense, cloud manufacturing represents the most suitable solution to provide services supporting the pairing and management of the different manufacturing offers and demands in the production network. So it allows to access remote distributed manufacturing resources via internet according to a service-oriented paradigm. But the employment of a cloud manufacturing platform represents an advantage for two types of target users. On the one hand, we have the customers, they have the jobs to do, and through the cloud, they can access to a wider network of manufacturing resources with many possible solutions to fulfill their manufacturing tasks. On the other hand, we have the suppliers that will be able to get new jobs through the cloud platform, increase their resource efficiency, because they can efficiently combine multiple jobs together. Well, in this figure, we can see the key idea of our cloud manufacturing platform that enables the sharing of distributed resources for efficient use at industrial manufacturing, industrial network. So the distributed manufacturing resources, as we can see here, are offered by different suppliers within the manufacturing network, and they are dynamically shared with users which are connected via internet to the cloud platform. And this platform collects the manufacturing services requests from the customers and the offers from the suppliers, and processes them through decision-making algorithms, which are intelligent algorithms, to find the best manufacturing solution according to the user needs and the possibilities offered by the suppliers. And this cloud platform includes 3 modules. A database module where the user input data are collected, then an intelligent assessment and optimization module, which is in charge of assessing the compatibility of the customer instance and the supplier instance and generate a number of suitable solutions using an intelligent optimization algorithm. And then we have a decision-making module for the evaluation and comparison of the different manufacturing solutions which are generated through the intelligent algorithms. And in this way, by employing the new cloud technologies, the suppliers and customers are globally connected to a common platform. So the opportunities to conveniently combine the different sheet metal cutting orders are notably increased. And in this way, the users remotely access a large number of distributed manufacturing resources via the internet technology. Well, here we can see the graphic user interface, which is available on the platform. Here, the users can create their own profile and they can enter their instances. And in particular, there are two types of instances, a customer instance and a supplier instance. And each instance contains some data, such as, for example, the material, the technology that has to be employed, the number of units that have to be created, the thickness of the parts, the due date, and then there is also the possibility to upload the CAD file of our objects, because this helps the intelligent algorithms define the better combination of different geometries in order to reduce material waste. Well, now I would like to give the floor to my colleague Alessandro Simeone from Shantou University that will describe in more details the different modules of our cloud platform. Thank you.
All right, thank you, Alessandra. Let me quick follow up the mechanism of this cloud platform. If I can go on with the slides.
Yes.
Right, share. Here we go. And here we go. I don't know if you can visualize. I hope so. All right, so as the customers and suppliers will submit their instances, including all the CAD files and the other data, then there should be a match instance here called functional compatibility evaluation. So imagine this as a sort of dating app for manufacturing services. Actually, this is a Tinder for manufacturing services. Now, how to evaluate a match? Match is certainly, from a functional point of view, done on thickness, material, technologies, and tolerances. Now, this one is the first step of compatibility. Then we need to evaluate a geometrical compatibility, and this is done through the use of genetic algorithm, because the problem is configured as a nesting problem and solved through intelligent algorithm. This kind of optimization will generate a number of different solutions. And then the real match is enabled by two kind of decision supports. One is for the supplier, which will decide the optimal production strategy, which can be nesting, queuing, or prioritizing their jobs or the customer job according to the amount of material utilization and deadline requirements. On the other side, the customer will be enabled to decide about the matching according to a number of different decision drivers. For example, the surface utilization rate, the energy, the reputation, or the processing time, or the distance cost, the logistics. And then upon agreement, the match actually takes place. Now, how does the matching actually happen? Imagine to have here a supplier instance with this geometry here, and on the other side of the world, you have another customer number one or customer number two. And then according to their geometrical requirements, the genetic algorithm perform this intelligent optimization, which is a nesting, in order to save and to utilize actually as much material as possible. We can see here a typical configuration resulting from the matching, from the nesting procedure. In this way, it's possible to utilize material as much as possible. Of course, different matches will result in different possibilities of pairings. And then the supplier's decision making will help the supplier to choose the best production strategy, which can be nesting, so doing products together, queuing the customer instance, basically append the customer instance once he finishes his own batch, or prioritize the customer instance. First, you do the customer, and then you do your own instance, or reject because there is no apparent compatibility. This results in a graphical, in this chart, we can see the different options. So all the possible combinations of strategies are characterized by different surface utilization rate. In this case, the nesting results to be the most optimal because it has the highest surface utilization rate, and since there is no incompatibility with the deadline, the supplier can decide to merge his own instance together with the two customers. In this case, the surface utilization rate will be highly utilized. So on the other side, what do we have? We have the decision making for the customer, and the customer can select his own supplier according to the number of suppliers. Do you want your instance to be realized by only one customer or more? And then the user rating, so the reputation, the surface utilization rate. The more, the less scrap material you have, the cheaper will be the price I'm going to pay. Processing time. Are you in a hurry? Can I wait until until you complete the job? Of course, energy cost. If you have a new machine which is energy efficient, then very likely I will pay less. And the other side, the distance cost will have certainly an impact on the final cost. In this case, we can see how the customer decision making is enabled with this spider web chat for an easy, of course, an easy and benchmarking among different kind of solutions. And here we can see, according to our own requirements, if we want, for example, if we are in a hurry, we will choose the fastest processing time. Instead, if we care about the reputation because we have high value products, then we will choose, for example, the user rating. Or anyway, we can compare here 6 different decision drivers. As a quick overview for the benefits, the supplier can effectively increase the material utilization. In the case studies we have published recently, we have an improvement up to 27% of material waste reduction for the supplier, while the customer certainly has the advantage of choosing his own preferences according to his own requirement. For example, minimum energy cost or processing time, highest surface utilization rate, so saving resources, shortest distance, save money on the delivery and the logistics, maximum reputation, and minimum number of suppliers. So these are the advantages that are result from this implementation of this cloud manufacturing platform. And I think from my side, that's all. I thank you. It's been a really great pleasure to participate in this event. And when there will be questions, we will be glad to answer. Thank you.